Hello everyone, I am Ovid Ghosh. In this video, we are going to see a brief overview on virtual power plant and different aspects of virtual power plant. That is, what is a virtual power plant, how a virtual power plant works, and different things about virtual power plant. So let us begin. First, what are VPPs? So, in a virtual power plant, basically different distributed generations like uncontrollable energy sources and controllable energy sources, also the energy storage and electrical vehicles, all these are aggregated and managed by a single control system. Uh, this varies to situation to situation. Sometimes there can be a single control system. Sometimes there can be a multi-layer of control systems. So here, uncontrollable energy sources and controllable energy sources means that uncontrollable energy sources are those which we cannot control, like the wind and solar systems. Their output and or the generation we cannot control, and the controllable energy sources are the conventional generators, and also the biogas generator whose outputs we can control. So these all are aggregated and managed by a control system. So an important aspect of the virtual power plant is that there will be a bidirectional communication between the components of VPP and external entities. Like the external entities means like the power market or the utility grid, like that. So basically, there will be three different bidirectional flows in the between the virtual power plant and the external entity. That is the power flow. Second one is the data flow. Third one is the cash flow. So in this video, the operation of the virtual power plant has been described. It is just a 1 minute video. If after watching it, you after watching it, the concept of the virtual power plant will be more clear. So let's start the video.
Technological innovation is managing to integrate renewable energies into our city's actual consumption. Virtual power plants, a new, more efficient and sustainable energy management system, are proof of this. Do you know how they work? Maybe you are already familiar with the concept of energy microgeneration, whereby a building or a household, for instance, can produce, store, and even share the energy generated through renewable sources. A virtual power plant clusters many of those microgenerators so that they can work together as a conventional plant by means of a centralized control system. What a virtual power plant achieves is to intertwine multiple sources concentrated in one area. Wind and solar power plants, storage batteries, biomass plants, and conventional energy generation sources, while coordinating them through a remote software system. When a certain consumer has run out of energy, he can have access to other sources. Or should a generation point have spare energy available, it can be shared with other consumers. There are plenty of benefits in this system. It allows to produce energy at a lower cost. It provides customers with enhanced flexibility. CO2 emissions are reduced, and since consumption points are very close to those where energy is generated, there's a decrease in the loss of energy during transportation. This system may make energy sustainable and efficient cities an increasing reality.
So hope you got the overview of the virtual power plant from this video. So let us continue. Hmm, sorry. So basically, these are the contents of the today's video. First, we'll see a brief overview of the architecture of the VVP, followed by the classification of the VVP. Then we will see the objectives of the VVP. Then the effect of uncertainties on the operation of VPP, and then at last there will be some research scope. So architecture of VPP. So here you can see in this figure, which is taken from this paper, it shows a typical architecture of the virtual power plant. So as you can see from the definition and everything, different entities like energy storage, conventional power plant, PV power plant, wind power plant, dispatchable loads, electrical vehicles, all are aggregated and connected through a local control center. This local control center also manages this all these entities, and the data exchange happens between this local control center and a cloud center, which exchange data on the market price, load, demand, and meteorological data. So meteorological data is basically required for the forecasting of the PV and the wind power plant. So on the other hand, market price data is required for the participation in the power market, and through this data exchange and the power exchange, finally the cash flow also happens between VBP and the external entity. So a special feature about the virtual power plant is its dynamic structure. What does it mean by dynamic? Dynamic means that each component here can be removed or added, as with, can be plugged out or plugged in at any time, like this. So here you can see in this slide, this all these entities are the part of the virtual power plant. But in this slide, the energy storage and electrical vehicles are not the part of the virtual power plant. They have been plugged out. In the same way, here you can see the solar power plant and the wind power plant has been plugged out of the virtual power plant. So this plugged in and plugged out system gives the virtual power plant a dynamic structure, which also causes an uncertainty that is very harmful, and that has to be dealt with properly. Otherwise, it will affect the operation of the virtual power plant. So now the classification of virtual power plant. So the virtual power plants can be classified based on a number of things. Like first, the based on the objective of the aggregation. So based on the objective of aggregation, the virtual power plant can be classified into two categories. First, the commercial, and second one is a technical. Whereas the main target of the commercial virtual power plant is to maximize the profit by participating in power markets. The main objective of the technical virtual power plant is to offer ancillary services to the operator of the transmission grid by controlling the voltage and frequency levels of the system, and thus improving the quality of the electric supply. So, based on the type of control, virtual power plant can be classified into three categories, that are centralized control, fully distributed control, distributed control. So, the centralized controlled virtual power plant have one control unit which controls all the aspects of VPP and have direct connection to the DERs connected to it. Now, the distributed control. So, the distributed control virtual power plant management takes place in a multi-level manner through the cooperation of control units of various level. That, for to give an example, a central control unit issues commands to lower order control units, and they issue commands to other control units or directly to the next DER. And the fully distributed control virtual power plant independently implement a control on the basis of data transferred by the VPP central control system. And this VPP central VPP control system has no direct impact on the functioning of the generating units or the DER. So based on the dispersion of units, the virtual power plant can be divided into two categories, that are distributed and focused. Where the distributed virtual power plants are connected to the external utility grid at different points, the focused virtual power plant will be connected to the grid only through a single point. So the objectives of VVP. So here you can see the main objective of the VVP is to always obtain maximum profit, and this can be achieved through through optimizing different things, and these all things can be categorized based on the section they are in. For example, Under generation units, generation income or the spinning reserve income, the VPP's income cost, capital cost, operational cost. Optimizing this, a VPP, it is possible for a VPP to obtain the maximum profit. Just like there are many options for the main grid, like the DM. The DM is the day ahead market, BM is the bilateral market, and IDM is the intraday market. So participating in this market and optimizing the process for participating, the VPP can achieve maximum profit. Also, there are three different ways for the end customers, for energy storage section, for the miscellaneous. So, a virtual power plant can participate at different markets based on the time scale it is participating. For example, before the dispatch of energy, a virtual power plant can participate in the future forward market and bilateral markets. And on the day before the dispatch, the virtual power plant can participate in day ahead market, ancillary service market, reserve market. And on the day of dispatch, virtual power plant can participate in intraday market, real-time balancing market. So let us know what are these different markets. So first, the future forward market. This market consists of purchase and sale contracts of farm energy for a specified period of time at a fixed price. Participation in this market allows the VPP to avoid the risks derived from the high uncertainty of prices in the day-ahead electricity market. And bilateral contracts consist of a direct agreement for the sale of electricity between the power generator and a buyer of the power. The both parties agree on a series of characteristics such as price, volume of the power delivery, and also the duration of the contract. In also, they can agree upon the minimum power to be supplied or consumed. Just like the future forward market, participating is the market gives an opportunity to guarantee VPP income by avoiding the uncertainty of prices in the day ahead market. So now the let us know about the day ahead market. So the day ahead market is designed to conduct electricity transaction for each hour of the following day, and this is done through the presentation of sale and purchase bids by the market agents. Now, the ancillary service market. The main objective of the ancillary service market is to guarantee the security and reliability of the electricity generation and transmission system. Mm, As the number of DERs will increase, poor management can lead to collapse of the grid, thereby failing to guarantee the reliability of the electric supply. So, if a VPP participate in the ancillary service market, this problem can be avoided. So, the reserve market. So, what is reserve market? The reserve market is a mechanism that allows additional generation reserves to ensure demand coverage and security of electric supply. The mechanism is increasingly necessary given the frequency of situations in which reduced margins of power reserves in the electric system are identified due to the growth of the non-dispatchable renewable energy. Now, the intraday market. Intraday markets are designed to adjust the energy traded in the day-ahead market with greater precision. Nothing but that. Now, the real-time balancing market. Real-time balancing market is the last market opportunity for balancing the production and consumption. The gate closure of this market typically ranges from between 5 and 30 minutes before the actual energy delivery. So, as we understand, the main objective of a virtual power plant is to obtain the maximum profit, and this maximum profit can be achieved by participating at various power markets at different time scales. Other objective, as day by day, along with the maximum profit objective, other objectives are coming to the scenarios and becoming very important. So other objectives of a VPP optimization problem may include the minimizing carbon emissions, minimizing operational risk, and maximizing social benefits. So these all are the secondary objectives beside the maximum profit. So which, if considering this other objectives, will make the optimization problem a dual objective optimization problem. And this type of optimization problem, solving this type of optimization problem is little bit tricky. So the maximum profit for the VBP can be obtained through two different strategies. First is the optimal energy management and scheduling. Second one is the optimal bidding strategy for various electricity markets. Mm, So, in this optimal energy management and scheduling, the main aim is to optimize the management and scheduling of different generation facilities, storage systems, and electricity demand to maximize the final VPP profit. The development of this model is primarily based on typical problems of technical economic dispatch. To maximize economic profit, this model create an objective function formulated as the difference between the system income and the costs. And these bidding strategies in these bidding strategies, the main aim is to maximize the operating profit while reducing energy production forecast errors and economic penalties due to the deviations in the generation of the uncontrollable sources. Now, uncertainties. So in this figure, it can be here different sources of uncertainty, and the reasons behind the uncertainties on those sources has been depicted. So first, for in the uncertainty in the renewable power mainly caused by the variation in the wind speed and solar irradiance. The uncertainty in the market price is mainly caused by the transmission network constraints, minimal supply and demand elasticity, and capacity limitation of the generator. And the uncertainty in the load demand causes by the seasonal changes, producing activity and emergency. So now the renewable power uncertainty. The uncertainty of renewable energy is mainly reflected in the intermittent and time varying characteristics of solar and wind power. In order to enable PPP to operate steadily, their varying characteristics should be fully considered in the design process. The uncertainty of wind power generation is mainly due to the randomness of wind speed, which is affected by the environmental factors such as territory. Similarly, solar radiation is the most important contributing factor affecting solar power generation. The solar radiation is characterized by the seasonal and diurnal nodes. So when the so as we are going to the future, to the renewable energy era, the capacity of the grid connected renewable energy will increase, and the power output will have a high periodicity and randomness, and this periodicity and randomness will certainly impact the safety, stability, and economic operation of the grid. So now the market price uncertainty. So, according to the US Department of Energy, the fluctuation in the prices of electricity can reach up to 359.8%. Under such violent fluctuations, market participants may suffer huge losses. Furthermore, the power market crisis may cause greater losses. So the fluctuation of market price has higher effect compared to the fluctuations due to the intermittency of the renewable sources. Load demand uncertainty. Load power is highly dependent on time, including the deterministic and stochastic parts. The increase in proportion of controllable loads, such as EV, will increase load demand uncertainty in VPP. Load demand is not only fluctuated with seasonal changes, but also related to the consumer psychology, current economic performance, producing activity, and emergency. It will make the uncertainty characteristics of the load demand more complicated. So here the uncertainty. So here in these three plots, the renewable energy uncertainty, market price uncertainty, and load demand uncertainty has been shown. How it is varying. So the load curve for 6 different days has been shown for IIT Hyderabad, and you can see load curves. Pardon me. not load curves, the renewable energy generation. So there is a 5 kilowatt rooftop solar system above the academic block C, and this graph represents the output of that 5 kilowatt rooftop solar system. So for 6 days it has been shown, and you can observe how the output of the solar system is varying, how tremendously it is varying. And for market price uncertainty, the prices of the Indian Energy Exchange has been shown for the 7 different days, and you can see the fluctuations in the daily prices. And it is highly fluctuating, which will cause an high uncertainty on the market price, and which will affect the operation of virtual power plant. And in this, for 7 days, how the load curve of IIT Hyderabad is changing has been shown. As you can see, the fluctuation in load is very high, and it will affect the operation of the virtual power plant. So how to address this uncertainty? These uncertainties has to be tackled, and how to tackle these uncertainties. So first step of the handling these uncertainties is to address them properly. So addressing them properly requires three different methods, like probability distribution descriptions, we all know about it. Then comes the possibility distribution. This is the extension of a fuzzy theory, as you may, some people may know. And this possibility distribution can help us to deal with the incomplete data, and get an probability distribution function for that incomplete data. And the interval description is used when they are not a great detail about the data available is known to us. Only the upper and lower level or boundary is clearly known to us. Then we use interval description to address this uncertainty. So after modeling the uncertainty, we can address this uncertainty and how to deal with them. That is the how to deal with them by these following methods. For renewable energy uncertainty, there is Monte Carlo simulation, robust optimization, rolling horizon approach. For market price uncertainty, there is first order stochastic dominance constants, information gap decision theory. For load demand uncertainty, there is fuzzy chance constant programming, interval analysis, point estimation method. So VPP has to survive by addressing these uncertainties. So here I will this Panda Power. So Panda Power basically is it's a library for the Python, library or package for the Python. So Panda Power builds on data analysis library Pandas and the power system analysis toolbox PyPower. So this Panda Power is used for the optimization in the power systems, also automation of the power system. And it is a very useful software, sorry, it is a very useful package if someone is working on the optimization of power systems. And using this Panda Power, one can also analyze and optimize different aspects of virtual power plant. So here you can see different benefits of Panda Power compared to other tools. You can take a look at this. Now the MESMO. MESMO is the multi-energy system modeling and optimization. So multi-energy is basically that you dealing with multiple energies at the same time. Dealing with multiple energies means, suppose we are only dealing with the electricity or electrical energy in the BBP. If we deal both with the thermal and the electric energy in the virtual power plant, then it become a multi-energy system. So using this multi-energy system MESMO library, it is also a library for the Python only, sorry, package for the Python only. And using this, someone can optimize the multi-energy system, and it is also a very useful tool. Thank you.